Hello everyone, welcome to the lecture 2. In this lecture we'll see how to graph different type of functions, and we'll do a little bit more things. This is gonna be a short lecture, so let's get started. So first we'll see how to graph different functions. So this is a straight line 2x plus 1. So this is how it looks like. X squared, we all know it's a parabola. This one we're going to graph at the end of this lecture, and then this is absolute graph of absolute value. So this is how it looks. This is like a hyperbola, square root of x. So first we'll try to solve how to draw a graph for 2x plus 1. So from the from the formula of straight line y equal to mx plus b, we know m is the slope and b is the y-intercept. So from this equation 2x plus 1, if we relate it with the formula of the straight line, so slope is gonna be 2 and y-intercept is gonna be 1. So we already know our y-intercept, so we can find our x-intercept. To find x-intercept, the formula is set y is equal to 0, or substitute y is equal to 0 and solve for x. So in here we are setting y is equal to 0 and solving the equation for x, and we get x is equal to negative half. So that's our x-intercept. We can also solve the y-intercept if this value is not given. In is the same way as x-intercept, but just opposite. To find y-intercept, we set x is equal to 0 and substitute x into the function equation. So we substitute x equal to 0 here and solve for y. Either way it can be done. Sometimes this one is more easy, or sometimes you can directly get it from the function. It depends. Sometimes if you do not have the x-intercept given, then you have to use this equation to solve it. But in this case it's already given, or you can find it in this way. I'm sorry, this is the y-intercept. I'm talking about the y-intercept. Now we found the y-intercept and the x-intercept. So y-intercept is when x is equal to 0, so y-intercept is 1 and x-intercept is negative half. So if we draw a line between the x-intercept and the y-intercept, we find the graph. Okay, this is a piecewise defined function. Few examples. So there is two function, 1 minus x, and its domain is from less than or equal to negative 1 to infinite, and another function is x squared. X is greater than negative 1. Like I explained in the previous lecture, if you have a if you have a clear circle, it means it's not included in the domain. If you have a filled circle, it means it's included in the domain. That's why this one is just greater than negative 1, and this is less than or equal to negative 1. The first function y minus x. So this is how so this is how the graph will look. And then it also asks to find the value of f negative 1, f1, f0, and f of negative 2. So you're gonna find it through the graph. So if you look into the f negative 1, f negative 1 is gonna be 2, f of 1 is gonna be 1 because it's a quadratic or parabola. F of 0 is gonna be 0. F of negative 2 gonna be negative, because of negative gonna be positive 3. From the graph we can do it. We can also solve it from the equation or from the function given. So for example, f of negative 1, it falls in the range of this function, because anything on the left of this, left of negative 1, this function is existing function there. So f of negative 1, we substitute negative 1 here, and 1 minus x, and x value is negative 1, so we substitute x with negative 1 and solve. We find 2. Same thing, x equal to negative 2, this is also going to this function in the domain of that function. So 1 minus x, and 1 minus x value is -2, so we're substituting x with -2 and we're getting 3. These two values are from this domain f equal to 1, because this function doesn't exist in this domain. So in this domain f equal to 1, we know it's a parabola. 1 is equal to 1 and f equal to 0 is origin. Okay, now the question that we didn't do earlier, we'll try to solve that. This is a quadratic function again, so there is two ways to solve it. So first we'll learn the method 1 and then we'll learn the method 2. The first way to solve it is find the x-intercept. So as we know, to find intercept we have to set y is equal to 0. So the function was y equal to x squared minus 6x plus 8. So we set that equal to 0 and solve for x. We get 2x's because it's a quadratic value. So if you have a degree 2, you will have 2 solution. If you have degree 3, you will have 3 solution. We'll get into that later. So once we find the x's, we find the midpoint. So the midpoint is x1 plus x2 divided by 2. So x was 4 and x1 was 4 and x2 was 2, and we add them and divide it by 2 and to find the midpoint. So the midpoint is 3. So we found the midpoint. So we all know the vertex is the minimum point of a parabola, and vertex has to be the midpoint. The minimum point of a parabola is the midpoint. So to find the midpoint value y, we have to substitute x into the function. So we substitute x into the function. So 3 square minus 6 times 3 plus 8, and we find our value of y. So that's our vertex. As I tell you, like, vertex is the minimum point of the graph or the function. So we found the vertex. Now we found the vertex, we found the two x-intercepts. So we draw a line through the vertex and two x-intercept and we find the graph. That's one method. There is another method. We can find vertex is completing the square method. So we will go over that. So we know there is formula x square plus or minus 2xy plus y square is equal to x plus or minus y plus x plus or minus y whole square. That's called a complete square. Sorry, it's called, this is complete square formula. Okay, so again, this formula is x square plus 2xy plus y square is equal to x plus y whole square, or x square minus 2xy plus y square, x minus y all square. It's a complete square formula. So we basically means if I multiply x plus y with x plus y, I'm gonna get x square plus 2x plus y square, or vice versa, x minus y whole square, x square minus 2xy plus y square. So we'll try to break this function into a complete square. So let's see how we can do it. So we have x square minus 6x plus 8. This doesn't give us a complete square function, so we'll try to make it work. So I already had an example written here how they did it. So x square, which is good, x square is x square. Then we have in the formula 2xy, so minus 2x, and this is 6x because we cannot change the function, so we have to multiply with 3 to make it 6x. Obvious, if we multiply with 3, that means 3 is our y. So if 3 is our y, then is y square is gonna be 3 square. But in the original function we had 8, but 3 square is 9, so we have to subtract 1. So if we added a 9 here, we subtracted 9 here, which gives it which cancel out at the end, and at the end we have a difference of -1, because initially we had 8 and we had because we had added a 9, so that's why at the end we are left with -1. But the function itself doesn't change, it still remain the exact same function. We are just rearranging the function to get the completing the square formula. So once we have this, from this we can see the x is going to be 3. If it is negative inside, it's going to be positive here. If it's negative here, y is going to be negative. So the vertex is going to be 3 and -1. I repeat again, if inside the bracket value is the x value, so inside the bracket if it is negative, x is positive here, and outside the bracket is y. If it is negative, it's negative. If it is positive, it's positive. So I'll end the lecture here, and that's it. We'll see you in the next lecture. And I will be posting these in YouTube as well. I will be updating the full course on Udemy. I will put the notes and the links to the Udemy once I have everything ready. Thank you.